MAT1033 Final Exam Review Question 26. Quadratic equation solved by using the quadratic formula. So let's refresh our memory on what the quadratic formula is. It's x equals the opposite of b plus or minus the square root of b squared minus 4 times a times c all over 2a. Okay, and our equation that we're given is 12x plus 2x squared equals negative 3. Now, the quadratic formula uses the coefficients in the standard form of a quadratic, so I need to identify a, b, and c, and in order to do that, I have to write this in standard form. So I'm going to move the 12x and the 2x squared. They're going to switch places. Commutative property of addition allows me to do that. And I'm going to add 3 to both sides of the equation in order to get this written in standard form. Then I identify a, b, and c. A is 2, coefficient of x squared, lead coefficient. B is 12, and c is the constant 3. Then in my formula, I would always recommend that you write the formula before plugging in. I need the opposite of b, which is the opposite of 12, negative 12, plus or minus the square root of, and let's see, I would also here recommend that you go ahead and square b before writing it in the radicand so that you don't have a sign issue. So b squared is 12 squared, which is 144, minus 4 times, now the product of a and c would be 2 times 3, which is 6. And then on in the denominator's position, 2 times a, which is 2 times 2, which is 4. Then all we have to do is simplify the radical and then reduce if possible. Okay, so I've got x is equal to negative 12 plus or minus the square root of 144. This is 144 minus 24, which is 120, and that's all over 4. Now, we do have two solutions. They're not in simplest form. 120 has a perfect square factor. Let's see, the biggest perfect square factor of 120. Well, I know 4 goes in there, so we can do that. We can write this as 4 times 30. Okay, and that's all under the radical there, just replacing that 120. And then 4 is a perfect square. Then you have to ask yourself, does 30 have a perfect square factor? Well, let's see. 30 is 5 times 6. So no, the only perfect square is 4. So we're going to find the square root of 4. X is equal to negative 12 plus or minus square root of 4 is 2 times the square root of 30, and that's all over 4. Okay. And again, oh look, 12 and 4 have a common factor, but 12 is not a factor of the numerator. It's negative 12 plus or minus 2 times square root of 30. So in order to cancel any common factor out of the top and bottom, I would first have to factor out a common factor in the numerator. And 2 is a factor that I can take out of both of those values in the numerator over 4, and now I can reduce. So my two solutions are negative 6 plus or minus square root of 30 over 2. MAT1033 Final Exam Review Question number 27. We're supposed to use the quadratic formula to find the solution of the given equation, which is a quadratic equation. So we first need the quadratic formula. X is equal to the opposite of b plus or minus the square root of b squared minus 4ac all over 2a. We have the quadratic equation given as 3x squared plus 2x plus 5 equals 0. And it's written in standard form. We can identify a as 3, b as 2, and c as 5. Then we're going to take these values and plug them in. X is equal to the opposite of b, which would be negative 2, plus or minus the square root b squared, so 4, minus 4 times, a times c is 15, and then divided by 2 times a, which is 6. 2 times 3 is 6. Then all we have to do is worry about cleaning it up and simplifying the radical part and then reducing if possible. Now this is 4 minus 4 times 15, which is 60. So that's going to give us a negative radicand, negative 56, which means we have imaginary solutions to the equation. X is equal to negative 2 plus or minus. 56 has a perfect square factor. 56 is what? 7 times 8. And then of course 8 could be 2 times 4, so 7 times 2 times 4. So we've got square root of 4 is 2. 2, negative, square root of a negative is I. And then 7 times 2 is left in, so that's 14 all over 6. We can factor out 2. Factoring out, well, you know, better yet, let's go ahead and separate the a part from the bi part, and then we'll reduce individually. So negative 26 plus or minus 2i square root of 14 over 6, and then we can reduce. So the two solutions are negative 1/3, reducing 26 to 1/3, plus or minus, and again 26 goes to 1/3. I'm going to have square root of 14 over 3, and that's going to be the I part of those complex answers. Let me show you what I did here. I canceled out, reducing that fraction and that one, and that's where the square root of 14 over 3 comes from.